Hi, my name is Michael Moreno. I've been working with Jason Hurst on this project. When we looked at building an LED project, we were looking to find something we could both use, and what we came up with was a temperature control unit for a computer. And the purpose of this unit is to prevent overheating while keeping noise levels down because some of the larger machines can be quite loud when all of the fans activate. The solution we came up with we are calling the TCS-1000, and what it does is it reads the current temperature and ensures that the current temperature is lower than the desired temperature input by the user. If the current temperature is not lower than the desired temperature, it activates the fans for the computer system. Now, when we designed this system, we realized we had to connect with 5 human drives, and the first of those is to acquire. And why would anybody want to acquire this unit? And the answer is quite simple. Computer fanatics look for the next thing, look for some reason to upgrade their computer and find better parts, and this would just be a different solution to the current ones out there. The next human drive is to bond. We have to make the user bond with our product. Why would they want to buy it? What kind of physical or mental emotions would go with the product? And computer users, they care about their computers, especially ones that have expensive computers, and they're always looking to find some way to take better care of it. The next drive is to learn. Users, unfortunately, are not going to learn much installing our product, and the reason for that is because we wanted to keep it extremely simple so anyone could use it. There are other systems out there that are a bit more complex, and they will teach you more, but we didn't want that complexity for the installation of this product. Next, we had to be safe, and our product inspires safety by keeping computers cool, ensuring that they don't overheat and smoke, by keeping the fans running only when they're needed. Lastly, the final human drive is experience. And users will experience silence when using our system. At least that is our hope, because some of the larger machines can be extremely loud, and especially if you have like 6 fans, so we wanted silence. When we looked at competitors, we found quite a few, and their products range from very simple to extremely complex. Seen here are 2 extremely simple projects that would be competitors. Some are just allow you to activate 5 different fans by turning the switches on and off. A couple of them would be like the dial, as you see at the bottom, where they allow you to regulate speed based on for several different fans. We did find an extremely complex unit, which would do way more than ours done, but unfortunately it was extremely expensive as well and very difficult to install. The price on this unit was $65, and it does way more than anyone's going to need. So when we looked at building the system, we had to design some way to make it all work together. And so we came up with this. Basically, the user will input the current temperature they desire onto using a temperature dial. This will go into a microcontroller. At the same time, the microcontroller will read a current temperature of the system from a temperature sensor, and then outputs the desired temperature and the current temperature to different LED lights. If the current temperature is higher than the desired temperature, then it will activate the fans for the system. This is basically a flowchart explaining that process. We turn on the unit, it runs the setup, it runs a loop, which checks the current temperature and the set temperature. If the set temperature is lower than the current temperature, it activates the fans to bring that temperature down. The circuit for this project looks extremely complex. In reality, it's not that bad. Basically, you have LEDs, which have resistors, and they all have separate pins. And then you have a motor, which is activated by a relay based on pin A3. You have a picometer, which is reading the temperature that the user desires, and you have a temperature sensor which reads the current temperature. Now all these pins you see here feed to the Arduino, which is this chip here. And this chip is the microcontroller. It's powered by a 9-volt battery, and it is programmable, which is really nice. When we looked at problems with this project, we had a couple major problems. The first one was lost variables. Our global variables were not sticking, and we found out later it's because our functions were void functions. We solved this by turning them into float functions, which then created another problem because you can't use floats in a greater than or less than statement. So we then had to turn those floats into integers after they were floats. It's a pain in the butt, but it worked in the end. The next problem we encountered was powering large volt fans. These fans are 12 volt, 10 amp fans, and the board cannot safely provide that type of power or amperage. So what we ended up using was a relay to bypass the board's power and to use a separate power supply, which is why our project has 2 batteries. When we went to prototyping, this was the first stage of it. It's called the TCS-1000, and it never worked. But it got the circuit down, and it taught us a lot about coding and a lot of other things. It was kind of cool, but it never worked. Next, we went to the TCS-1000. This one was functional for the most part. It had temperature sensors in it that worked. The LEDs would give you the current temperature. It had a working picentometer, which read the desired temperature for the user. The motor never worked, though, and we could never figure out why until after we finished the project, when we realized that the motor was just a bad motor because we plugged it straight into a battery and it didn't even work. The TCS-800 was our final rendition before the final design. And basically, we had everything working. We just upped the housing and used a different motor because, of course, the other one didn't work. It was a bit bulky, but it was functional. Previous ideas, we had quite a few when we looked at building this project. We had stairs, and we were going to put a sensor on them, so when you stepped on them, it turned on LED lights, but we only had one sensor, and it wouldn't have worked as well with one sensor. We also looked at building a light for a keyhole, but it was too simple. Future ideas, funding would be helpful. Building a project on absolutely no money and nothing is extremely difficult. Even like a $30 budget would have been awesome. So in the future, when building projects, it's going to be a great idea to try to find some money to do it with. Lastly, when we were looking back, we were trying to find out what we were doing as far as the project, and the most important thing we found was we wanted to keep it versatile. We wanted to be able to do other things with it if we needed to. And we solved that by this system can be reprogrammed to do heat and cooling, and it can be do a whole bunch of different things. It just needs a little bit more programming and a little bit more work, which unfortunately we didn't have time to put into it. But we realized that versatility is basically the key in everything.